Okay, so here are our notes about periodic trends with magnets. So this is in case you were absent, you can follow along. You won't have the Bohr models to kind of play with, but you can watch as I do them. All right, so the first thing is we are going to review a little bit about atomic structure. So we have our three subatomic particles, protons, neutrons, and electrons here. We're going to go ahead and label where those at. So this out here on the outside rings, this would be my electron, remember, okay, or E, written this way. These would be my protons because they're positive, or P. And then the ones that aren't labeled with a charge in the nucleus is my neutrons, or N. Okay, so it says in the atom, the protons and neutrons are in the nucleus. The electrons are in the orbitals s, p, d, and f that spin around the nucleus. And protons are positive subatomic particles. Neutrons are neutral subatomic particles, and electrons are negative subatomic particles. Okay, just a little review of the structure. All right, next thing it says in the Bohr model of the atom you have been provided. This means the magnets, okay, and I'm going to show you what it looks like here. Okay, that's talking about. In the center represents, so because they're in the center and they have a charge, they're going to represent the protons and has a positive charge. The magnet on the ribbon that can freely move in the energy levels. So we have here we have a Bohr model, okay? Remember, those are in the nucleus, the protons, and they're positive. That's why they have a charge. We're not saying they're the neutrons because there is a charge. And then we have a ribbon here with an electron, and this electron can move around, and it is attracted to the protons in the center. Okay. The magnet on the ribbon that can freely move freely in the energy represents an electron. Okay. And has a negative charge. So they are attracted to each other because protons have a positive while electrons have a negative. All right, so let's take a look at the atomic radius, okay? So the first trend, okay, we're going to talk about is atomic radius. And the radius of an atom is measured from the nucleus. So this is a measurement which we do in actually picometers to the valence electron. Remember, those valence electrons are the ones on the furthest outer energy level, okay, the highest energy level. The radius of the atoms will change as you go across a period or a row or down a group, which is a column. You will place a magnet on the string in the positions below and write if the attraction to the center magnet increases or decreases. You will start with the magnet on the string in the first shell or energy level, okay? So we're going to do it in the second, then we're going to do it in the third and the fourth. Okay, so we're going to take our one with our nucleus here. Okay. Okay, we're kind of bright here. Let's see if my thing will adjust. Okay. All right, give me 1 second. All right, so here we go. That's much better. All right. So we have our first one, and we're going to start in the second shell. So we're going to start in the second energy shell. And as you can see, it's kind of, when I let go, it's kind of, it's attracted. Okay, so when we go from the first shell, it really is pulling, okay, in that first shell. But when I move it out to the second one, I have a hard time holding it at the second one, or the first one it wants to go, is the second one, okay? The second one, though, it seems to have decreased a little bit. And as I go out to the third, it's really easy. It just kind of flips around. It's holding up, but it's laying down, if you notice. Because when I go back to the second, see how it kind of lifts up? And then the fourth, it decreases. So as we move out, which means we're increasing in energy level, that attraction is actually decreasing. Okay, so we're going to write that down. Okay, so as we move to the second shell, the attraction to the center of magnet decreased. And then as we went farther and farther out, it decreased even more. Okay, so you can think as those electrons or those valence electrons move farther from the nucleus, from the positive nucleus that they're attracted to, that attraction decreases and the atomic radius increases. So as you move the string farther away from the center, you are moving across a period or down a group. So as we went out from first energy to second energy to third, that is actually going down a group on the periodic table. Okay? So how do I know that? I know that because as you add more energy levels, this is first energy level, second, third, fourth. You're actually adding. When you go across a row, such as the second, they all still only have 2 energy levels. Okay? So we would be going, as you're increasing those, you're going down a group. Okay? Okay? And would this represent an increase or decrease in atomic radius? So you can think if you only have one shell, that's a small radius from the nucleus out to the valence electron, and then it starts to get bigger as you go from go down a group for the first energy level, second, third, and fourth. So it's an increase. Okay. Therefore, as you move down a group, the atomic radius increases. Okay? Because your outermost electron moves farther from the nucleus. Okay? All right, now let's try something new. As you move across a period, the number of protons is increased. How do we know that? Well, remember the number of protons is the atomic number. So as we go across a period, such as lithium to beryllium, notice it goes from 3 protons to 4. So we're increasing that atomic number. So we're increasing atomic number, which means we're increasing the number of protons, okay? So now place a string, it says, I'm going to do this in just a minute. Now place a string. So place another magnet in the center so there are 2 protons, okay? So now, if I have 1 proton, let's see how their traction, okay, is. So you can see kind of is, I'm not going to hold the tip, I'm just going to put it in there. So you have a little bit of attraction. If I let go, it usually moves towards it. Second one, I can let go, it doesn't, and at third and a fourth. But what if I added a second proton? So now I have 2 protons. Now this attraction is really high inside the thing. But if I put it on the second one, it does want to pull a little bit towards the center. So as you increase the protons, as you can see, because I can take 1 off again, and if I let it go, it does not snap on. But if I add 2, watch the attraction of that now when I let it go. Okay, so there's more attraction. The more protons you have, the more attraction you have. Okay. So as you go across a row and you increase those protons, those electrons are going to move closer to the nucleus, okay? So it says, how does the attraction change as you get closer? Okay, it increases. Okay, which energy level is the strongest? It is the first energy level, okay, the closest it is, right? Okay. And which energy level is the weakest? It would be the 4th one there. Now take away the proton and repeat, just like we did. How did it change? When you had less protons, the attraction was decreased, as you saw just a minute ago. Therefore, with more protons, the electron would be more attracted to the nucleus, as you saw, okay? Which means as you move across a period, the protons increase, which will cause an electron to be more attracted to the nucleus and decrease the atomic radius. So the closer it moves, okay, the less of the radius. So let's look at that again. Okay, so I have it here. I have my electron. As I move it closer, okay, it is attracted, but it's not getting pulled except till we get to the first. And then, of course, it gets pulled in. But if I add here, oops, if I add more protons, okay, as it goes closer and closer, or even as it gets there, it's going to be more attracted. To put a stack. There we go. More attracted to the center. So as you can see, it's more attracted to the center. The more protons, if you put in the first energy level. So it's not too attracted in that first one. It's a little bit, but notice what happens when I add more protons, how it just flies to it, okay? So the more protons you have, the more attracted that electron is to the center, and so our radius will decrease as you move across a row, okay? All right, next trend we're going to talk about is what we call ionization energy. What the heck is ionization energy? So ionization energy is defined as the energy required to remove an electron. Okay? And so what does that mean? Well, if I'm sitting here and I have an electron that's attracted to the nucleus like this, it doesn't just fall off. I actually have to use my energy or use my hand to pull it off, okay? And of course, the closer it is, the more energy you need to pull it away. If it's really far away, the less energy. So let's look at this, okay? So it says on your paper, it tells me, place the string in the first shell or first energy level and observe if it is hard or easy to remove the magnet. We're going to start with just one, okay? And we're going to put it close to the energy level. It's not too bad, but it does take me pulling, okay? Okay, a little bit, okay? So it does take some energy. Okay, and it says, then move to the other energy and make the same observation. So we're in the first energy level with just one magnet. Yeah, okay, it takes some energy, okay, but when we get to the second one, it doesn't take as much, and the third, and you can feel that pull is really light, okay? So at the first energy level, we're going to say it's kind of hard, okay? And then less energy, and then this one's easy, okay? And you can see, let's even look, and we'll talk about what happens when we go across when we actually add more protons. So as you go up in energy level, this is the same thing as moving down a group. Remember, as you go to more rings, that's going down that group. Therefore, ionization energy decreases. As you saw that I went out, it decreased as you move down a group. Okay. So now it says we're going to place the string now in the third energy level. So I'm putting the third energy level. And note how hard it is to remove. It's pretty easy. I can pull it out. Okay. And a second magnet to the nucleus. So now, again, we're going to add a second magnet. Means more protons. Okay. Is it harder or easier to move that electron? And you can feel there's a little more pull as I got there. So with the extra proton. And even You can even test it in the first one. So in the first one, it's not too hard, but let's add another one. What happens when I add more? Now I actually have to slide it off, okay? And so that does make it a little harder. So it is going to be harder, okay? Because there's more attraction. The more protons, the more attracted it is. And increasing the number of protons, remember, it's like moving across. You're increasing that atomic number, okay? So it's like moving across a period on the periodic table. Therefore, ionization energy increases as you move across a period, okay? All right, so that's that first one. Now what we're going to do is we're going to talk about electronegativity. So ionization energy, as you move across a period and increase the number of protons in the center, it's going to be harder to remove that electron. So it increases ionization energy, but as you go down and you go up here in energy levels, you're moving that electron across, so there's less attraction, so it decreases, okay? All right, now let's talk about our last trend we're going to talk about here in this unit, and that's electronegativity. And the electronegativity is defined as the ability, okay, of an atom to take an electron from another atom, okay? So we're going to take our second Bohr model. So our second Bohr model has an electron glued on, and you're going to place your string back into the bag. So we're going to put our little string with our electron away for now. And make sure you only have one proton in the nucleus. So we're going to have one proton in the nucleus, okay? All right, so let's see what happens. So I have my Bohr model has one proton in the nucleus, and I have my other Bohr model, which has my electron, okay? And you're going to place the second Bohr, I'm going to place the second Bohr's model electron to the fourth energy. Is there any attraction? Kind of, but not really, okay? So there's not a lot of attraction. So in that first one where it says, is there an attraction? There's little, okay? It's very little. Now we're going to move that second one closer to the center in the lower, and let's find out how that is attracted. So I'm going to move it closer, and I'm going to move it closer, and I'm going to move it closer, okay? And now once I get to the center, it is a little more attracted, okay? So as you decrease the radius, right, because I'm decreasing the radius here, the attraction to this gets greater and greater, okay? So what is happening to the attraction? It is increasing. Okay, so as we just watch this happen, it says is there an attraction? There's a little bit of attraction, and then it says what is happening to attraction as I moved it closer until it increases. Okay, so you can conclude that as atomic radius decreases, remember as I moved it closer to the center, the ability for the protons to attract the electrons from other atoms, because that was another, increases. Okay, so the closer those can get, right, to the center, or the closer they are, the smaller that atom is, the more they can take electrons from another atom. Okay, all right. And so since the atomic radius, remember, decreases as you go across a period, because remember those electrons are more attracted to the center, more protons, then the electronegativity increases. So the smaller those atoms are, the more it can take things from other atoms, take electrons. Now we're going to move the electron to the higher energy levels. What is happening to the attraction? It will decrease. Okay, so let's see that happen. So as you saw, as I moved it farther and farther, there is less of an attraction, right? I can let it go and it doesn't go in there. So as I move it farther and farther away, there's less attraction to the nucleus, okay? So you can conclude that as atomic radius increases, the ability for the protons to attract electrons from other atoms decreases. So as the atoms get bigger, okay, or on this side of the periodic table, that electronegativity increases, okay? And since the atomic radius increases, as you go down a group, then the electronegativity decreases, okay? So as they get bigger, they have less attraction to the nucleus because they're bigger, just like I was showing you just a minute ago, and that causes the electronegativity to decrease, okay? All right, so we're going to just kind of summarize kind of what we've done here, okay? And as it says, as you go across, so these are all across a period, these are down a group. So as we go across, the atomic radius decreases. Remember, we have more protons. So there's more attraction to the center, okay? And as we go down a group, the atomic radius, we have more energy levels, so the atomic radius, and I'm going to turn this sideways, increases, okay? And that kind of drives the other two. So as atomic radius decreases, as they get smaller and smaller and smaller, well, electronegativity is the energy to remove it. So it makes it harder. As the electron moves closer to the center, it's harder to remove it. So this increases electronegativity. And then electronegativity, as you go down a group, remember it's moving farther and farther out. So that radius is increasing, which drives electronegativity. And so it's easier, okay? And you need to remove it, so you need less energy. So as you go down a group, because it's getting bigger and bigger and farther away, it decreases. Okay. Then we'll talk about ionization energy. Again, ionization energy is driven by that radius. As the atom gets smaller, because the atomic radius as we go across a period is getting tinier and tinier and tinier, it can attract electrons from other atoms easier the smaller it is, okay? So electronegativity increases. Remember electronegativity, it's becoming our ionization energy. It's the energy to remove an electron, so it increases, takes it harder and harder. Sorry, I got those two confused. So ionization energy, the smaller it is, the harder it is to remove, the more energy it needs, okay? And the more protons you have, get my other proton, the higher the attraction. So notice, boom, boom. Now we're going to get attracted really well, okay? And I will get attracted probably in the second one, okay? And it just takes it, okay? So it increases. Energy to remove that electron increases. And as we go down, because we're getting bigger and bigger, yes, we're increasing the protons, but we're moving farther and farther out. That radius is getting bigger. Then my ionization energy and my electronegativity, sorry, you can't really see me, decreases. So these two decrease. As radius increases, electronegativity and ionization energy decrease. And as atomic radius decreases, the other two increase, okay? All right, so put these into your notebook. If you have any questions, please let me know.